In question 6a, we're given a statement and we must determine whether it's true or false. The statement is, two angles are vertically opposite if and only if they are equal in size. The phrase if and only if means that the implications must go in both directions. For this statement to be true, it would have to be the case that two angles being vertically opposite implies that they are equal in size, but also if two angles are equal in size, it implies that they're vertically opposite. If we think a bit about this second implication, we run into some issues. It is not the case that angles being equal implies that they're vertically opposite. To illustrate this, I've drawn a little diagram. The angles A and B here are alternate angles, which means they are equal. However, they are not vertically opposite. So we've shown that it's possible to have two angles equal in size, which are not vertically opposite. This means that the statement is false. In part B, we're presented with two diagrams of a rectangle, ACEG. In diagram A, various sides and angles have been labelled for us. We're told that GA has a length of 90 centimetres, AB has a length of 20 centimetres, and BC has a length of 30 centimetres. We've also been told that three of the angles in this diagram are equal. They've all been labelled with theta. In diagram B, the lines GE and BD are extended to meet at a point H. These two diagrams will be helpful for the questions on the next page. In B part I, we must prove that the length of FE is equal to the length of EH. And we're told to use congruent triangles in our proof. In diagram A, the angle DBC was labelled with theta. Since the lines GH and AC are parallel, we can use alternate angles to deduce that EHD is equal to theta. We're told that ACEG is a rectangle. This means that the angles in each of the corners must be 90 degrees. In particular, the angle FED will be 90. We know that FH is a straight line. Since angles on a line must add to 180 degrees, we know that the angle FED plus the angle HED must sum to 180. It follows that HED will be 180 minus the angle FED. We already found that this was 90, so we end up with 180 minus 90, which is 90 degrees. Now that we've filled in some of our angles, we're ready to compare the triangles EFD and EHD. The angle EFD is equal to the angle EHD because they've both been labelled with theta. The angle FED is equal to the angle HED since they're both 90 degrees. Since the three angles in a triangle always add up to 180 degrees, once you know two angles are equal, it must be the case that the third angle is equal. It follows that the angle FDE is equal to the angle HDE. The triangles also share a common side, ED. Since we've shown that the angles on each end of this side are equal, it follows that the triangles are congruent by ASA, angle side angle. In congruent triangles, the side lengths are equal. Since FE and EH are both opposite the green angle, it follows that the length of FE and the length of EH are equal. In part 2, we must find the size of the angle theta. To help us here, I've copied out the measurements from diagram A. We were told that GA was 90 centimeters, AB was 20 centimeters, and BC was 30 centimeters. This information can be used to fill in some other side lengths. The first thing to observe is that AFHB is a parallelogram. We know that AB is 20 centimeters and opposite sides in a parallelogram are equal, so it follows that FH is 20 centimeters. In the previous part of the question, we showed that FE and EH were equal in length. This means that the 20 centimeters for FH is split into two equal parts, 10 centimeters for FE and 10 centimeters for EH. Focusing on the original rectangle, the bottom side, AC, has a length of 20 plus 30, which is 50 centimeters. It follows that the top side, GE, must also be 50 centimeters. Since FE is 10 centimeters long, there's 40 centimeters left over for GF. Now, if we draw our attention to the theta in the right angle triangle AGF, you'll notice that the side opposite theta is GA, which is 90 centimeters. The side adjacent to theta is GF, which is 40 centimeters. In a right angle triangle, the tan of an angle is equal to the opposite over the adjacent. So we know that tan of theta must come out as 90 over 40. To find theta, we just need to get rid of the tan. We can do this by taking tan inverse of both sides. When we calculate tan inverse of 90 over 40, we get 66.0375. Rounding this to the nearest degree gives us our final answer that theta is equal to 66 degrees.